All right, so this module is going to be about the network monitoring and tools that we'll use to do that. So again, in the past, we've talked a little bit about different attacker tools, etc. Now we're going to talk about what's considered the blue team, so to speak, of how to monitor what's going on within the network and how to explain how that monitoring is actually conducted. So with monitoring itself, in order to mitigate all these threats that we talked about, networks need to be secured and protected. We talked a little bit in the past about firewalls and IDSs, or intrusion detection systems, as well as IPSs, intrusion preventions, and then endpoint security software to protect. All these methods and technologies are used to introduce automated monitoring, as well as creating security alerts and automatically blocking those offensive devices. In large networks, there's an extra layer of protection. Usually this is the firewalls or the IPSs with pre-configured rules in order to find out whether that traffic should be handled accordingly. And important to that cybersecurity analyst is to review all those alerts generated by the system and the collection of those set alerts in a particular central focal point. So with these, the day-to-day operations of a network consist of monitoring traffic flow, bandwidth usage, and resource access. These identify normal network behavior. So it's important to set a baseline, particularly with what your network is, so you can see when things are different than what they normally should be. Different tools you could use are packet analyzers, SNMP, Netflow we talked a little bit about. Those are some other ones that are out there. The most common ways to do this are called network taps, or what they refer to as test access points. Typically, this is a switch which has a span port, or what they consider to be a switch port analyzer, or port mirroring. The idea is that you're taking traffic going from one point to another point. You're going to put a tap on that. Think of the old government, and putting a tap on that particular line only in a network fashion. So you're seeing the traffic that goes across there as if you are the target, but you're not injecting any traffic of your own. You're just simply monitoring what's going on. So there's different kinds of network taps. The first one is a passive splitting device, which is implemented in line between a device of interest and a network. This particular tap, like what you see here, is going to forward all traffic, including physical layer errors, to the analysis device, and then allowing the traffic to reach its intended destination. So traffic will come in from the firewall to the network tap, go down here from the receiving, down to the monitoring device, back from the transmitting, and then back out in order to get to the initial router there. So it's kind of interesting to see how these taps work. You have the transmit, which is often referred to as TX, and then the receive line, which is RX. This ensures that all data will arrive on the monitoring device in real time, and taps are fail-safe. That means that the traffic between the firewall and the router is not affected. There's other ways to do it, which would affect traffic. When capturing network traffic, it requires all traffic be captured. Special techniques such as port mirroring we talked about on a switch must be employed to bypass the network segmentation imposed by network switches. Port mirroring enables the switch to copy the frames that are received from one or more ports on a switch port analyzer, or a span port, that is connected to an analysis device. And then this table kind of explains what span is. So these are pretty easy to understand. I mean, you got your ingress traffic, egress traffic. Your span port, again, this is just a configured port, typically on a switch. And then you have a destination port where you're going to send that traffic to. So you can say that you want all three ports are listed as source span ports, and you can send all that traffic out the destination port. You just need to be careful not to try to flood that particular network. So for example, if those are gigabit uplinks and you send 4 of those over to 1 gigabit link, you may have a little bit of an issue. You'll more than likely need to have a much heavier or bigger pipe here, like a 10 gig pipe that's a span port. So just like you see here in this particular diagram, in this case, you're going to have some 1 gig ports coming in here. Well, on this, or I'm sorry, a fast Ethernet, so 10100. You're going to collect that data, send that out a destination span port, which is a gigabit connection to an IDS sensor, and then onto a management sensor. And then you're going to end up forwarding that traffic back out the egress port of the FO2. So again, a span port on the remote span, if you're doing this on a remote network, that allows you to then traffic that back over VLANs in order to monitor that traffic from a remote location. All right, so some other security monitoring tools. You're going to have some network protocol analyzers. These are your Wireshark and TCP dump. Netflow, remember Netflow is going to take samples of data traffic as it's going through the network. This is a Cisco proprietary one. There's also SFlow, which is open source. JFlow is available on Juniper devices. There's several others. And then you also have a SIEM system. The SIEM is a security information and event management system. This is typically where all this data is collected together. So it's common for security analysts to rely on the log files and the SNMP coming from these particular devices to monitor what the network behavior should look like. So if we look at network protocol analyzers, again, Wireshark is just a GUI version of something like TCP dump. The protocol analyzers will show us what's happening in real time, or not necessarily real time, as it won't be a capture unless you have that on the device. Protocol analyzers are used for a security analysis, but they can also be used for troubleshooting networks. So if you're seeing a flood of different traffic come through, you'll also see that as well. You can see the kind of protocols going across the network. You can see the different types of traffic that goes through there. But there's better tools to use than just trying to use Wireshark for everything, because this is way more detailed and a little harder to trace these different communications, or what they call conversations, in between each one of these. So as you see here, Wireshark is just being used in all Windows, Linux, and Microsoft operating, or Mac OS operating systems, and it's useful for that. What you see here, Wireshark will save things into what we call a PCAP file, or a packet capture file. It'll have all the information about the data going across the network. Those packets can grow to be extremely large, because if you think about it, everything that goes across the network is being dumped to a file. So Wireshark can open these files and you can view them locally, or you can use them remotely with TCP dump. And again, here's a picture of TCP dump, analyzing or capturing packets of ping going back and forth. So notice you have your ICMP echo request and then the replies that come back from those particular devices. Notice these IP addresses flip-flop as they go through there. WinDump is a Microsoft variant of TCP dump. You also have what's called T-Shark, which is a Wireshark command line similar to TCP dump. All right, so as I mentioned before, Netflow is going to be a Cisco proprietary iOS technology that provides analysis for 24/7 statistics on packets that flow through the network. It's a standard for collecting IP operational data in IP networks for Cisco devices. And Netflow can be used for security monitoring, as well as network monitoring, planning, traffic analysis, trying to figure out where one traffic is going from the other, etc. And it provides a complete audit trail of basic information of just about every IP flow forwarded on the device. Although flows are stored in information in local cache, it should always be configured to forward onto a Netflow collector, which stores the Netflow data. So you'll generate it on the device itself on cache, but you should offload that data and send that to a collector, which is usually a SIEM system or something like that. It will monitor the connection by tracking byte and packet counts for that particular individual application flow. It'll push those statistics out. So as you see here, you're going to have a Netflow enabled router. It's going to send traffic out through another port through this switch, and typically down here. Again, you're sending every packet or a good amount of traffic going through here, depending on what you set in the configuration. As Cisco StealthWatch notices here, it could collect Netflow statistics and allow flow stitching, which is putting groups together. You can do flow deduplication, which will filter duplicate entries coming from multiple Netflow clients, as well as NAT stitching and simplify flows with NAT entries. This is all, again, kind of a Cisco proprietary section. There's other collectors that you can use with Netflow. One of the most popular ones I used back in the day would have been Cacti, which is kind of an open source system. There's several other ones out there today that'll do some real handy graphing. MRTG was one. PRTG is another. That's a paid for one. And that's actually what I've used in data centers, is the PRTG product. With SIEM and SOAR, with SIEM, these are your security information event systems, as we mentioned multiple times, which is a technology used in enterprises to provide real-time reporting and long-term analysis of security events. This can help you provide forensic analysis, the ability to search through logs and events, records, etc., for Reporting, you can also do correlation, so you can see when logs and different events happen and put them in real time, and then you can use detection in order to react to those security threats. You can aggregate all this information together, which is going to keep you from having to go get duplicate records from different systems. And last but not least is the reporting. You can aggregate this data where you need to in real time, or have long-term summaries if you need to go back and find out what's been going on the network, and generally what has changed during that time. So the difference between a SIEM and a SOAR: a SIEM is going to help provide details of suspicious activity, user information such as username, authentication status, location, device information such as a manufacturer model or Mac OS, etc. And then you have SOAR, which is your security orchestration, automation, and response. This enhances your SIEM. It's going to help security teams investigate security incidents and add enhanced data gathering for a number of different functionalities that aid in the security incident response. So SOAR solutions, these are going to provide case management tools that allow your cybersecurity personnel or your help desk personnel to research and investigate these incidents, frequently by integrating threat intelligence into the security network platform. A lot of times they're using artificial intelligence now in order to detect and aid in these incident responses. Automate complex incident response procedures, generally performed in the SOC, or the Security Operations Center. And now it allows that staff to run different books and et cetera. Books are just going to be little scripted programs to automate and pull information back. It offers dashboards and reports to documents for incident response to improve SOC key performance indicators and enhance network security for organizations. An open source product called Security Onion, which is what you'll use during this course, includes an ELK for SIEM functionality. ELK is an acronym that puts 3 different products together from Elastic. So you have Elasticsearch, which is going to be a document-oriented full text search engine. It's going to allow you to scan documents really, really fast. This can be incoming logs, etc. You also have Logstash, which is going to pipeline process of inputs and outputs with optional filters to filter out those different logs. And then you have Kibana, which is a browser-based analysis statistics as well as search dashboard for Elasticsearch. So it gives you basically a GUI or a dashboard for this Elasticsearch. SolarWinds has a security event manager, as well as Splunk is another very proprietary and popular SIEM systems used by SOCs. So Splunk is one of the biggest ones I've seen out there. There are several SOCs, like even the ones that were here in Hayes at the local ISP. They were using SolarWinds for the longest time. I'm not sure if they currently still do or not. All right, so there's some packet tracer activities you can certainly go through and see how to log network activity. This is going to help you, see credentials going past there, as well as the exchange of syslog messages. All right, so to summarize network monitoring in this particular module, it's a very small module. To mitigate the threats, all networks should be secured and protected with a defense in depth approach, which means you should have multiple layers of security. This requires security infrastructure such as your firewalls, your IDSs, your IPSs, and then endpoint security software. As a cybersecurity analyst, you need to review all alerts that are generated by the devices and validate them. Tools such as IDS, packet analyzers, SNMP, Netflow, etc., are used to determine normal network behavior. You want to make sure you set those baselines. Again, I can't stress how important that is. And many times that I've gone back and tried to troubleshoot network and security issues, if we didn't have a solid baseline or a long history of what had been going across that network, it's very hard to lose sight of what is changing within that network. Makes it even more difficult to troubleshoot. 2 common ways that are capturing that traffic is to send it to network monitoring devices, such as network taps, and traffic mirroring with using span ports or port mirroring. And then common tools that you guys will always use will be network protocol analyzers, such as Wireshark and TCP dump, also a combination of Netflow and a SIEM. Again, protocol analyzers are just programs used to capture traffic. Netflow is going to be a Cisco proprietary feature, and that one's going to provide statistics on packets, generally through a router or a multi-layer switch, and that can be used for network security monitoring, etc. SIEM is a technology that's used to provide real-time reporting and long-term analysis of those security events. You can think of this as kind of your dashboard for security analysts, log tickets, etc., things that come in. And that is the conclusion of this module.